Okay, so before we start today's lesson, we're gonna deal with some funny, interesting exponent questions first. So we've been dealing with exponents in the past few classes, and that's what we're going to continue to do this class. We're gonna be learning more about solving exponents, and let's see. 2 to the what power equals 32. So obviously, if you know a little bit about 2, that's the 5. And then 3 to the what power equals 81. So usually when you have these type of questions, you want to break this down like this. So you have 3 to the x times 3 to the 1, which is actually just 3, so you can get rid of that. So now when you realize that, when we learn about multiplying these together, we're actually just adding the exponent. So it'll be x plus 1. So just so you know that. Now we have 3 on the left and we have 81 on the right. We can do 81 divided by 3, which is going to get you 27. So if we do this, it's going to give us 27. And now x is just 3. Because we know 3 times 3 equals 9. 9 times 3 equals 27. And that's pretty simple. Now, how do you get a negative to become a positive? That's obviously when you do negative 1 to the 0, it's going to equal to 1. Very simple. And then for this question right here, you're actually doing negative 1 to the power of 1, which is negative 1. Because anything to the power of 1 is itself. So basically 2 to the power of 1 is 2, 3 to the power of 1 is whatever. Negative x to the power of 1 is negative x, and such so on. So here, we can actually do this. So 2 to the 2 to the x is equal to 16. So now we have 4 to the x equals 16, which is this 2, because everybody knows 16 is a perfect square and 4 squared is 16. Always try to break down the exponent, and this one is the same thing. However, we're dividing it instead. Equals 36 and 66. This is 36. So 36 times 36, that's 1296 equals 6x. And this is just calculator work. Times it yourself. Do whatever. You should know that the x is equal to 4 in this case. Now, I'm going to be showing you a strategy on solving these, after we do the entire class. That is not supposed to be in grade 11 functions. But trust me, if you know this method, you're never going to use other methods. So first, we have solve using a common base. So what is a common base? Usually, this is the base. Base to the exponent. Sorry, base to the exponent. So whatever number this is the base. So in this case, we have 4 and 2 as a base. So, how do we get 4 to become a 2? Well, we have 2 to the second power of x plus 1 is equal to 2x minus 1. And then obviously when you have these, we can times it out together. So 2 to the 2x plus 2. Remember, there's actually a bracket here, so you have to, FOIL correctly. And now this is an algebra question. Everybody can solve it. So x plus 2 is equal to x minus 1. Since the base is completely the same, we just have to solve this. So we'll do it, we'll isolate x to this, and then we'll move y negative 3. And right here, we can go ahead and confirm the answer. Negative 3, if we have negative 3 on the left, let's go up. If we have negative 3 on the left, that will be 4 to the negative 2, which is going to be 1 over 16. And on the right, we'll have 2 to the negative 4, which is 1 over 2 to the power of 4. And obviously, we all know 2 to the power of 4 is 1 over 16. And then left side equals right side. And we did our question. So that is solving a common base where we're using the left and right side to become one base. However, that is exceptionally rare to find in the real math world, simply because it's just hard to find. And then we will have rational solutions. So what is rational solutions? Well, essentially, we're still going to try our best to turn that thing back to a regular, to a function first. So we have this on the left. But instead of trying our best to go ahead and do all that and find a common base, which we can actually in this case, but we're not going to do that. We're gonna simplify the 9 first. So 2 to the 3x and 9 to the 3x and 9. Remember, we used that earlier. We broke it down. And then on the other side, we have 27 to the power of x. And let me just check. So we will then, yeah, we'll still have to break this down to a common base. So we'll do 3 squared to the 3x plus 1 is equal to 3 cubed to the x, and then we'll have 3 6x plus 2 is equal to 3 to the 3x, and then we solve 6x plus 2 equals 3x, which will get you 3x equals negative 2. And finally, with all that done, we're going to get the answer of x is equal to negative 2 over 3. And that was our final answer. And then you can go and check that, but this is a rational solution simply because we have a fraction as our final exponent. And then we have solve using a common factor. This is when we're common factoring on one side. So remember what I said earlier, you can break it down. So I thought that was the breaking down for the other question, but I guess not. So let's do 1/6. So here we're going to factor this out as a common factor. So we'll have 3 squared minus 1. Since we factored it out, it's equal to 1 now, to 1/6. And now you'll realize in the bracket we actually have a finite value, and that is 3 to the second power, which is 9 minus 1, which is 8. So 3 to the power of x times 8 is actually 216. And then 216 divided by 8, that would end up being 27. So 3x is equal to 27. So x is equal to 3. And that is everything you have to know for this question. Now we have a word problem, and let's read. A radioactive isotope, iodine 131, is used to determine whether a person has a thyroid deficiency. So thyroid is one of the glands that you have in your body. That's part of biology. So the iodine 131 is injected into the bloodstream. A healthy thyroid gland absorbs all the iodine. The half-life of iodine is 8.2 days, so its decay can be modeled by the exponential equation, which they gave you the exponential equation right now. But when you get into that unit, you're going to have to create that yourself, which is not the fun thing, not the most fun thing to do, because I've seen so many students make mistake on that. But that's okay. Where AL is the amount of iodine 131 left, the AO is the original amount, and T is the elapsed time. In days, how long should 25% of the iodine 131 remain in the... Okay, so 25%. So let's start with actually just turning this into a fraction, which is something we need to do because it's hard to work with percent. So we have 1/2. Oh, sorry, 1/4. So AL, instead of AL, we're actually going to have 1/4 of AO. So instead of writing AL on the left side, we're gonna write 1/4 because this is we need 25% of iodine left. So that is gonna go ahead and equal to AO 1/2 of T8.2. Now you might be able to see something. Look, there's AO on both sides. Let's just cancel it out. Great, you see that? So let's just cancel it out and rewrite the entire thing. 1/4 is equal to half to the T of 8.2. Now, if you can't see it already, we can directly turn this into a same base, or we can turn it into a base of a fraction. So if we have 1/2, we can have 1/2 squared is equal to 1/2 T over 8.2, and then we have to solve T is equal to 8.2 times 2, and then you'll get 16.4. Or you could have changed that to a fraction of 2. It would be like 2 to the negative 2 equals 2 to the negative 1, and then you do that. This is more complicated, but most people like dealing with regular numbers simply because they're more used to it. But however, it doesn't really matter. So remember, you are going to always write your units. So 25%. Okay, so when you have this much, when you only want 25% left, your units is in 16.4 days. Now, this is pretty simple to do. You could have just done it directly. You were like, oh, look, 50% half-life is 50%. So we have 50% left. 50% is 8.2 days. So if we take another half of that, it's going to take another 8.2 days, which is just time 2. You could have done that too, but that's not the purpose of a math course. So if you want to do it the math way, here we just did it. Now let's do some practice questions. These practice questions are very straightforward. I'm just gonna do 2 for you. 2 to the what? 2 to the a. 2 to the fourth power is 16. B. 3 to the third power is equal to 27. And then for 2, we're gonna have 7 to the w minus 2 is equal to 49. So basically for this, we can actually write 7w over 7 squared is equal to 49, and then we times this out, which is 49 times 49, and then 49 times 49, we can solve that to become 7 to the what power, 7 to the w power is equal to 2401. And then we're going to solve from there, whether it's direct, you're looking at the answer and you're be like, oh, I'm going to times 7 by 7 by 7, and you count how many 7s you're doing, or you're doing the complex way and be like, oh, I'm going to do my algebra and stuff. And then that should be the rest. It's pretty straightforward. They're just adding fractions and stuff. Now, remember I promised to teach something that was not part of the regular curriculum. And here I am. I'm going to do that right now. So, let's see. So, we're going to learn something about log. So, when you're going to learn this in advanced function, I'm going to tell that straight away. So, what log does, it's going to have a base. So, log base, and then, well, okay, let me just write it like this. So, b to the power of e is equal to a value. So whatever, so let's say 2 to the power of 3 is equal to 8. So when we log 2 and 2 to the what power equals 8, we should be able to get an answer of 3. However, when we have x's, this is much more simpler. So we have 2 to the x power is equal to, let's say 64. So we're going to add a log in there. So when we add the log, we're going to drop the exponent to the front. So the x becomes to here, x of log 2. And remember, when you log one side, you have to log the other side. This is just math. When you divide, or when you multiply one side, you have to multiply the other. The simple algebra rules, never forget it. So when we log the 2, we also have to log the 64. But whenever we log something, we always drop the power in front of it. So now we're facing a simple question. X equal to log 64 over log 2. Now, there's no way I'm wrong, but correct me if I'm wrong. So log 64, you do that on your calculator, you're going to get a finite value. And when you get that value, you're going to go ahead and divide it by log 2, which is 1.8 divided by 0.3 something. And then that is going to go ahead and give you 6. This is some simple log rules. If you want to learn more about this, I'm going to make an advanced function video, but this is pretty much all you have to do. You just have to log the right and log the left. And remember that log, you're actually having a base. However, when you do not enter a full form of log, you just enter log, it's automatically going to log base 10. And I'm not going to say anything too much about this because I don't want to spill the fun for your future classes. But whenever you assume log to be 10, and you just do it to the left, do it to the right, you're always doing log base 10. So it doesn't matter exactly what your base is. If when you can do log 4 to the 2, log 4 to the 64, as long as you have the same base on the left and right, no matter what log you input it, you're always going to get the same answer of 6. Now let's just confirm 2 to the power of 6 is equal to 64. And that's all pretty much about this exponential part. It's basically solving some exponential equations. However, we're going to do much more of this as we step into the exponential equation unit, and pretty much this is all you get. Make sure to do your homework. Please practice, practice, and practice.